What I'll do is let me answer some questions, though, universally that came up during the break, because I think it's important to understand about this for operators. One is there is this thing called Operator Hub I/O. Right? That's how you find your operators and try to deploy them to your clusters. Right? It might work in your cluster or not. You'd have to kind of read the documentation and read the support information behind it. These are not all provided by Red Hat by any stretch of the imagination. Here's one provided by Amazon, whoever Atlas is.
Are only to use in OpenShift, yes?
No. You can run them, as long as your Kubernetes cluster is configured correctly, it'll run in your Kubernetes cluster also, but it depends on the vendor. So Couch Operator, the Couch database people, they might say, no, only OpenShift. So you kind of have to read through the documentation. You kind of have to read through the docs. Maybe you have to contact the vendor. But they're all supposed to work in OpenShift and Kubernetes. Yeah, so these aren't OpenShift only. We never intended for that to be that way. We have the largest customer base of Kubernetes customers, so a lot of people build for our distribution only, but that was never the intention. Like the Crunchy folks, I'm pretty sure the Crunchy folks do work on Kubernetes as well as OpenShift. All right, that's Postgres. That's a highly available Postgres with an operator to manage it, right? So it and keep in mind an operator, which again is kind of the fancy version of a CRD. Let's see here. You can also, if you look, this one basically has the first three: basic install, seamless upgrades, full life cycle. So what these guys do is kind of cool, right? The basic install is kind of like what we saw with the Kafka thing. It installed my Kafka broker for me, right? I basically, boom, and it's up and running. It handles that. Also, it'll handle upgrades. So in other words, when the vendor ships a new version of that image, okay, like in the case of Red Hat with stremz and all that, if we ship a new version of Kafka, because we have a supported version of Kafka, and if you want that version, let's say a major critical vulnerability was fixed in it, it'll upgrade also. You can set it for automatic upgrades. And then you can also see here it's got backup and failure recovery. Now, and this is which one are we looking at right now? We're looking at the CrunchyDB PostgreSQL, so that one is in this category. And then you can see how much further it goes. So these things get very, very sophisticated, but it's just a block of code that someone had to write that basically responds to those Kubernetes events, watching for those things coming and going, making sure these things are handled correctly depending on the type of software you wish to run. The whole point of what we're seeing with the CRDs, controllers, and now these operators is to make your Kubernetes cluster feel and behave just like it was Amazon itself or Google itself or Azure, Microsoft itself, right? Meaning it's a cloud provider. It's just that it's your cloud now. That's the real distinction here. Okay? And then the stremz one that I was just showing you, it's all out there on GitHub. It's all open source. And the tool you would use, you can use the tools, one called MetaController, right, to build controllers. And notice right here, it even tells you, basic stuff. And here's how well, that's not what I was looking for. Is it getting started? Right, like decorator controller. Oh, I was on a different page earlier, and I can't remember what it was. But it tells you how to build your own custom controller. And then there's a thing called the Operator SDK. Operator SDK. God, I can't spell today. Operator SDK. There we go. Again, an open source out here on GitHub. This is, again, something we've open sourced at Red Hat that tells you how to build your own custom operators as well. So CRD, controller to do the basic stuff, and then operator sits on top of that to do kind of the more advanced things, like I got to have zookeepers and a broker, right? It's just more intelligence on top. All right? Okay, well, let's kind of get back into this and kind of show you some more cool things. We got lots more cool things to show you. And where'd the slide deck go? Did we wait long enough for the person said we wanted to wait? Okay, so that was the demonstration I showed you earlier. We had the messaging worker on different clusters or different clouds, and we ran it that way. We showed you stremz and kind of the idea of the CRD through a Kafka CRD. That's, again, a very powerful concept, right? You can build your own custom definitions. Let's kind of go back and talk about some of the other 12 ways. And one of them is this concept of your deployment lifecycle. I make a point of this because if you're in the mental model or your organization is happy with their 3-month deployment cycle, Meaning we deploy every 3 months like clockwork. Our team is a machine. We deploy every 3 months. And your customer, your business, your product manager, your boss is super happy with that. You don't need all these things I'm telling you today, okay? This stuff is way overkill for you if you're happy with your 3 month, 3 month, 3 month. And the reason I make that point is because the new world is living in 1 week deployments, not 3 months. Or the new world is living in everyday deployments, not every week. And if your competition is living in this world, right? So if you're doing this right here, you're deploying every 3 months, you have a certain trajectory, right? You have a certain batch size and capability and speed. And then if your competition is deploying every week, they're on this trajectory. Over time, they just blow right by you. That might still be okay based on the type of software you're dealing with. For instance, I only work on an internal human resource database that manages the vacation time for our employees. The employees aren't all going to quit if I don't deploy every week, right? They're happy with every 3 months, as a matter of fact. That might be okay, right? Until basically someone in HR comes along and says, you know what? I can get that as a SaaS service. I don't need you, Mr. Programmer, anymore, deploying every 3 months. The SaaS service updates every day with a new feature. I want that instead. It's only going to cost me $5,000 a month, and I'm laying you off. That's your competition now, okay? So you got to think about that. So I love this quote again from Bruce Lee. Those who are unaware they're walking in darkness will never see the light. That's how you have to think of it from this perspective. So if you have your monolithic application right here, you kind of have, you know what your application looks like. I can deploy it every 3 months. I can get my arms around it. But now we're dealing with a world where the application itself is really a series of modules, a series of components. And we actually start thinking of these things as microservices, and our application feeds into the background, right? So our application is now gone. We now have these microservices, which together make up what we thought was the application. And we distribute those microservices in a way, in all their little pods in Kubernetes land, there are all these little pods running as microservices, and now there's a network between them, right? The pod is the computer. Therefore, if I go pod to pod, there's a network traversal there, pod to pod, okay? And so if we've done this microservices thing correctly, we have a network traversal in there. But we did this on purpose to ourselves, believe it or not. Now, again, you might be thinking, yeah, it was a bad idea. I want to go back to my nice 3-month deployable monolith versus this model. But you chose this model because you want to deploy faster than every 3 months. You chose this model because it was too much code, too big a team, too long a duration for that deployment model you had before. Now, all these microservices, of course, have their own database because we're going to go super fast. Each of these are independent teams responsible for their data, responsible for their microservice. They practice DevOps, Agile, CI/CD, and they deploy every Thursday. Every Thursday. And what we'll show you with Istio is you can deploy every Thursday at 9 o'clock in the morning, because there's no downtime for deployment at 9 o'clock in the morning on Thursday, even with all your users on the line. All right? You can have multiple points of entry to these microservices. It used to be you had one front door to your monolithic application. It was a certain URL you went to. It had a nice user interface with your login, and you basically use the application through one point of entry. Now we have multiple points of entry because our microservices all have nice APIs, and sometimes our business partners want to talk directly to our APIs. So now you have to think in terms of API governance and API gateways and how you're going to manage those APIs. But the part that gets weird is that each of these components have a team associated with them. They have their own pipeline definition, their own deployment interval. They have a complete deployment independence so they can ship their microservice when they need to respond to their customers. That's why you chose this architecture, so everybody can go as fast as they need to go. Some teams might be like, oh, I only deploy every 3 months. Fine. You stay slow, you be happy. Right? This team over here has got to burn it up because their customers are demanding new features all the time or bug fixes all the time. Or more importantly, even if you don't want to go fast for the sake of fast, one thing I love telling people, if you've ever had to teach a teenager to drive, I've taught 3 to drive. One of the things you talk to them about is speed kills, right? Now, maybe here in Poland, you don't let your teenagers drive cars until they're 22. So they're not actually teenagers anymore. You got to wait till you're 21 before you can drive a car, maybe? Maybe not? 19? Okay, so they're still a teenager. In any case, it doesn't matter when they start. You teach them speed kills, go slow. And we have that same model as adults when it comes to producing software. Go slow, it's safer. I'm here to tell you slow is actually not safer in the world of software because you're going to have a critical vulnerability in your Java libraries, like the struts2 vulnerability that Equifax kept in production for months well after everyone knew it was a vulnerability. As a matter of fact, it was so funny. I put it in a presentation to discuss the Struts 2 vulnerabilities with my audience to talk about why you want CI/CD and DevOps, because here's a great vulnerability that it's a 0-day vulnerability. What that means is when you know about it, someone's already hacking it. And I literally had a printout from a newspaper report where the Chinese had already written a bot to look for this vulnerability on your site the same day it shipped that you knew about it, and then break into your code through your web user interface. A couple months later, Equifax came out with a news report that said they lost 150 Americans' records through these doors, right? So in other words, my point is the CVE and going slow in the face of CVEs is actually much more risky. You want to go fast. You want to go fast so you can patch things fast. At least respond, even if you don't care about features. So these are all the microservices principles. We don't have time to deal with these. This is a whole presentation by themselves. But you can live in the old school world and be super happy. Or you want to live in this new school world with distributed microservices and functions and things like that, cloud native architecture, but that's really where something like a Kubernetes really starts to shine. Is that fair? Okay? So if you look at the microservice-ilities here, you got to think in terms of how you build an API, manage your API. You got to figure out what your service discovery mechanism is, your invocation model will be. Is it elastic, meaning can I easily scale it out and scale it back? Is it resilient if it falls over and dies? Am I falling over and dying? What's the pipeline I use to basically ship that component out to the production environment? I got to think through my authentication, my authorization model, my encryption model, my logging, my mentoring, my monitoring, my tracing. I got to think through all those things as part of my infrastructure now. I got to have something to solve these problems if I'm going to let my development team start throwing all these microservices at my architecture and my infrastructure. So if you're on the ops side of the house, you got to start thinking about these kinds of problems. How am I going to do tracing in this world where I've got 45 things talking to each other? How am I going to do monitoring and logging? How am I going to do logging at scale? Because I don't know if you know this, but logging can fill up your disk drives a lot faster than a database can. You guys probably have seen that in some of your applications, right? So let's actually show you some of these microservice-y things, okay? Right? We're going to actually show you something here. So let me find my namespace that I want to be in. And actually, let's switch over here. Kubernetes, Istio tutorial. So this is an application now where it's set up. It's supposed to be super simple, but it has 3 pods, 3 microservices, which are all independently deployable. Okay? And you can see there's customer, preference, and recommendation. So just like you saw me do earlier with producer and consumer, there's 3 little microservices that all talk to each other. Customer calls preference, preference calls recommendation. And the thing that's kind of neat about that, okay, is I can say kubectl get services here. There's services for these guys. Let's see them. There's a customer service, a preference service, a recommendation. There's the 3 pods. Okay, there's going to be my deployments. These are all the standard objects. There's nothing unusual here. It helps if you spell the object name correctly. These are all standard Kubernetes things. So I have my deployment. I have a replica set. A deployment creates a replica set. A replica set creates a pod, right? See, desired 1 pod, current 1 pod, ready 1 pod. And you can see it's been up for 43 hours. Apparently, I launched these a couple days ago. And there's my pods, customer, preference, and recommendation. So this is our microservices architecture, super simplistic to kind of make the point. Now, notice one thing right away that's kind of different here. Instead of 1 for 1 like normal, it's 2 by 2. And that is because there's a sidecar riding along now. There's a sidecar that basically is managing certain aspects of this application for me. And we're going to talk more about that in a second. But just be aware that there's 2 things instead of 1 thing like we saw earlier. And so if I come over here and basically say, let's see, poll the customer. All right, there we go. We're polling the customer. We're doing customer preference recommendation. And you guys can play along with me here as well. That is bit.ly Istio customer 2 on your phone. And let's go back over here and here. All right, so there we go. So I'm basically interacting with this endpoint. You can see and there's a counter here. It's a single JVM running in a single pod, so that counter is just a count plus plus. Okay. Notice also it's returning this string right here, which is the host name it thinks it's running on. So this is actually the environment variable called host name you get in Java. So in Java, I said, hey, what's my computer name? What's my host? And it returns this string, which is right here. It's the pod. That's the computer in which this Java piece of code, Java code is running. And you guys have it up? And all you can do is refresh, and you notice you're getting a different number based on whatever number you see being hit down here versus whatever number you're hitting. It's just a count plus plus. Let me bring up my Safari, just to kind of check it out over here. Okay, come on, Safari. There we go. So the network is a little slow, but all right. So watch these two things now. So you guys have it up on your phone. Now let's actually have a little fun with this. I'm going to do some things super fast, and then we'll walk through it a little bit more slowly based on the time available. But I built a bunch of scripts here to make it a little bit easier for myself to remember everything. I'm just kind of checking things out here. So let's go here. So let's do the 5. We're going to deploy a second recommendation, a version 2 recommendation. All that is yet another deployment, kubectl get deployments. Now we will have 4 deployments. Recommendation v2. You can see it's coming online. Notice it's 0, 2. Then it'll be 1, 2. Then 2 of 2 right there. And then once it gets ready, all the way ready, and it goes 2 by 2, you'll see it then part of the load balancer down here. And let's go back over here. Come on, come online. And then you'll see it 50-50. So there it is. It's now showing up 50-50. And the reason you're not seeing a clean 50-50 is because I'm interacting with it through my browser. You're interacting with it through your browsers. Notice the number here. So now you notice it flipped back to V1. It is 50-50 load balancing, but for all of us. Okay? And that, what you just saw, is standard Kubernetes behavior. Nothing fancy yet. Kubernetes basically says if you deploy 2 pods, I'll load balance across the 2 pods. If you deploy 8 pods, I'll load balance across the 8 pods. If you have 2 pods, it's 50-50. If you have 4 pods, it's 25, 25, 25, 25. It's a very simple little bit of load, round robin load balancing. And the way the magic happens is if I come over here now, and actually let's do this, kubectl get pods, show labels. Just kind of so you can see the magic. Here is the labels associated with this. You can see it says app recommendation there, app equal recommendation. And if I go look at the services, got to spell services correctly, and we do a, come on now, recommendation is the service name, so kubectl, describe, service, recommendation. Let's dig down in here. Notice the endpoints. There's 2 of them. You see those right there? Those 2 are the IP addresses. Let's see if I can do this. Wide, is that in here? And yeah, so you can see right there, there's 26, there's 26. Here's 65, there's 65. Notice also with the wide, this is on this worker node, this is on this worker node. So they're actually on 2 different computers, 2 different worker nodes in my overall Kubernetes cluster, and I'm load balancing across them, but you, the user, are completely unaware of this. So this by default is kind of the magic of Kubernetes, right? This is what you got out of the box for free. And now a blue-green deployment is super easy, right? You can now have a lot of fun with this. But what we want to introduce now is this concept of a Canary Roll Out and do some really kind of fancy stuff with it. So if we look over here, kubectl, get CRDs, grep virtual service, right? There's a virtual service CRD out there. There's also a destination rule. And these are new special object types that come from the Istio team that I've installed on this cluster. And that means if I create objects like the Kafka thing we did earlier, a virtual service type and destination rule type, those controllers kick in, and those now manipulate the network traffic going across these pods. And that means I can do really fancy stuff, really crazy stuff here. So let's see if we can try to show you what this looks like. Yeah, let's do this. Are you guys still hitting it? Well, let's try one more thing. Okay, let me go right here. And I'll show you this. We're going to make everybody version 2. So on your phone right now, it's all version 2. Everybody's version 2. Come on, Firefox, you're version 2. So there's a simple change there. I have rolled out version 2. Everybody has version 2 now. But I want to kind of show you how this magic works. All right, so was this the right one? Yeah. So Istio files. The destination rule looks like this. So here's, again, see the kind destination rule? It's a destination rule. And all it does in a destination rule in this case is set up, I have 2 options, version 1, version 2. I'm simply declaring the options that I have. If I had 3 options, you'd see a third one there. And so you can see the name is version 1-v1. That is its name. So it's important to remember that string. And if we look at our virtual service down here, so let's go with version 2. Notice this one. Again, it's a kind virtual service. And right here, you can see that it says, OK, I'm going to send everybody to version 2 100% of the time. 100% of the weight of all transactions, the weight of all the traffic goes that one direction. So that's exactly what's happening right now with this. OK? And so again, this is just another document type within the concept of the Kubernetes API. So I can do things like kubectl get virtual service. And you're going to see there is one now, right? It's called recommendation. See the name recommendation? If I go back and look at the YAML that was uploaded, the name is recommendation. That's where that name came from. And so if I want to do kubectl, let's do this. Let's see if I can remember how to do this all right. So echo kube editor. Don't have it set. All right, so export. I'm doing this from memory. I have not. I have a script for this. Let's see if I can get it the right first time. Equal to q code dot, no, dash w. All right, and now, so kubectl edit virtual service recommendation. If I did that right, it pops up Visual Studio Code. And now notice that I'm actually editing the object in the etcd database, in the Kubernetes API. I'm not editing the YAML file on my disk anymore. I'm editing the one that's in production. So this is actually a really awesome feature. Everything is done in Kubernetes in a declarative way, including a virtual service, the deployment, the Kafka, all that I can also just edit. So let me see if I can hack on this a little bit. I'm going to make it now version 1. Save, so I hit save, close, come back over here. If I did that right, and we're all v1 now. So this basic concept, that's not how you would normally do it, right? You wouldn't do that in production per se. You wouldn't want, the average developer or operations team just hack it on those YAMLs like that. You want to hack on the YAML, check it back into source control, punch it through a pipeline where you might have some automated testing, and then roll it out in production. I'm just having fun. But this concept's incredibly powerful if you think about what we just did here. So if you are practicing a blue-green deployment, right, where I have an old version, the new version, I can basically flip all my users to the new version and go, holy crap, that wasn't what I wanted, flip everybody back. So this concept right here is a huge win if you are practicing that fast cycle time, CI/CD. I want to deploy every day, deploy every week, and I want to deploy so fast that our QA team, we have a 12-person QA team who normally spends 2 months testing the software. Yeah, you can't use them anymore if you're going to deploy every week. You see the difference between 2 months and 1 week? So those folks aren't doing anything manually. They're doing everything in an automated way. But this gives you a little bit more protection of if you deploy something that was bad, and you're going to see that next, what happens if I deploy something that's bad? Okay, so we're going to show you some of this stuff. So let me keep going here, and I'll walk you through some more of this. We're already on v1, so that's not going to make a change. Let me do an 80-10 split. So this is actually more what you will do in the real world, is this 80-10 split, so the weight of 90 and 10 when we look at that YAML. But you'll notice that there'll be a couple of v2s. About 10% of the user transactions will be going to version 2. You can see it right there, and there's my version 2 right there. So even you guys right now, if you're using your phone, you'll see a version 2 or so. So this concept, again, if you look at that YAML document, let's see if we can find it real fast. It's one of these mini options here. That's 50-50, 75-25, there's 90-10. So that's the one I deployed with my script. So you specify the numbers. The reason this is incredibly powerful, this is actually beyond Kubernetes behavior. Kubernetes, by default, 2 pods is 50-50. 4 pods is 25-25-25. Now I'm doing 90-10 with 2 pods. So with Istio, it can be really fine-grained. I only want 1% of my users going to the new version. In this case, 10% going to the new version. If you did 1%, we might have to wait a while to see it. Okay? But this is concept of a canary deployment. You guys have heard the term canary deployment before? Right? So the concept of the canary in the coal mine is where the word canary comes from. If you're familiar with coal mining, they take a little bird in a little cage down inside the coal mine, and it has 2 great values to the coal miners. One, they have a nice pet. It makes noise. It flutters around in its cage. It's a nice, pretty yellow bird. But if the little yellow bird falls off its perch, you know to get the hell out of the coal mine. because the canary dies faster than the humans when poisonous gases are found within a coal mine, which is actually a common concern. So that's the concept of the canary in the coal mine, and therefore we have this concept of canary deployment. What if we deploy something to 10% of our users and it's not good? Well, I can fix it right now. I can roll it right back. Okay? So,
What about Black Canary?
What's that?
What about Black Canary? Can you do that with Istio?
Oh, yeah, we're getting there.
Good.
All right? So if you think of a black canary the way I think of a black canary, and there's the black canary, the cartoon character, right, from DC. Not that black canary. Yeah, I didn't, it's an arrow, I think. Yeah. Okay, so I actually, what I did here is I deleted the virtual service and the destination rule, so therefore we've gone back to old behavior, 50-50. And so let's kind of look at this, right? Let's actually deploy another canary model. So in this case, a different canary model. You're going to basically see all the users here going to version 1. And then my Firefox users are going to version 1. But my Safari users are going to go to version 2. So this is an important thing to understand. So this is not the dark canary, the black canary. This is a still semi-light canary. But it's only for a certain group of users. So let me show you that one. Here it is. So here you can see I have a regex where I'm looking for the user agent. If Safari is in the user agent, and by the way, don't test this on a Mac with Chrome, because Chrome also says it's Safari on a Mac. You guys know that old trick. If you've been around the web development game for a long time, right, everybody says they're Firefox, including IE. Chrome says it's Safari. That way they can trick websites into thinking they're different browsers. This has been a thing we've been doing for years. So you got to test this really with Safari versus Firefox, because Firefox does not claim to be Safari. Chrome does.
Even if you have something from Apple, you will pay for a higher price.
If you have something for what?
If you use hardware from Apple, you will pay a higher price.
Oh, good point. That's true. If I know you're on the Mac OS, I can just charge you more money. You must be rich. Okay, I'm good with that. I like that idea. So you could use this feature for that. Okay? So, but you can pick what you want from the HTTP headers. You can decide if it's a cookie, it's a user agent, it's the Mac OS versus the Windows OS, or whatever it might be, and you can further refine who sees the canary. So you can actually, in the default application that they show you with the Istio thing called, it's called Bookstore, if you're logged in, you get a slightly different user experience than if you're not logged in. And one thing I always like to tell people, you can be logged in and you're a user who's checked the beta box. If so, we're going to set a cookie, and you're going to see it all throughout these transactions. And notice also, this is happening at the recommendation level, which is 2 steps in from the head. So this was always doable with really fancy routers at the front end. It was never doable down the mesh. Yes, sir?
And what happens if you kill version 2, especially in the previous...
Kill version 2?
Yeah.
yes. So
If you don't scale the port.
No. All right. So if we kill version 2, it's a fair point. So, get pods here. All right. What? I should have left this on. This is why I like having this, get pods. All right. So I can basically say, all right, if you kill the pod.
Well, I mean, downscale it, not kill the pod, because it will already start eventually.
Well, it'll restart, but it is down momentarily. Whoop, I didn't. It helps if you spell cube control correctly, cube cuddle correctly, hit return as well. So it's down right now. If I catch it fast enough, all right, it's dead.
Yeah, but here is understandable. It's routed based on Safari, but what happens if you just doing this 90 by 10?
So I would, in this particular case, I would actually want at least 2 pods of version 2 to have a little HA. But it's still going to route based on, those 2 within that 10% or within Safari or whatever the routing rules are.
Yeah, so if it hits the dead version 2, it will just return 5 of it.
Well, and actually what you'll see in a second, depending on what error you have, in this case, I caused the error, okay? If it's not something you want to do, it actually will route around it automatically. So we'll see that here in a second, okay? So let's do this. Yeah, we did that one already. So 12, we'll clean out our canary. So we'll go back to standard round-robin load balancing. All right, so let's talk dark launch, right? So this is the dark launch concept. So right here, I'm doing my dark launch, and what you'll notice right there. Okay, so right here, you'll notice everybody's on version 1. Version 1. This should be on version 1. And if you pay attention, you'll see that v2 is still being logged. So the logging, it's just looking at the logging activity for version 1 and version 2. And you can see there's still version 2 logging happening there. That's the bright pinkish one that you see coming through there. That's the version 2 log, basically getting recommendations. And here's the reason that's important. And so let's see if we can show you that one. All right, so where is our mirror and our dark launch? Always forget what the name of that file is. I could go always look at my script, make it a little easier for myself. Let's see, it is the destination rule recommendation 1, and it's the one with mirror in it. So I should have known that. Where's the one with mirror in it? There it is, right there. So you can see right there's got the keyword mirror. And so the concept here is version 1 is in production. Version 2 is also in production, yet no user can see it, no users. That's the point of this one. So is this what you think of the black canary? Yeah, so I call this the dark canary. The concept is very straightforward. I still have the canary deployment. I deployed it. But I don't even want anybody seeing it. But I want to basically take some traffic, send it to that component, and what I'm going to basically do is now monitor it for potential issues. So in other words, I'm looking for, is it coughing up 503s? Is it eating all its memory? Is it killing, if it's dying and restarting because the liveness probe and readiness probe are failing? Is it filling up its disk? Is it throwing out exceptions into its logs? I can monitor all those things and then decide, oh, it seems to be working okay. Let me open up the aperture to maybe 1% of my users now instead of 0%. So this is essentially a 0% deployment, and I can move it to 1, or 1 and Safari, or 2% for people who've checked the beta API box. You can decide how clever you want to be there as to how many users get access to it. And again, this is something that's incredibly powerful if you are practicing deployments all the time, right? Because we're moving fast here. This application component needs to deploy right now. And so this concept's very powerful. And one thing I didn't do here, but let me go ahead and bring up, because I forgot about this. Let's go here. Let's go to my routes. Let's go to the route specifically for Istio system. So you can kind of then be monitoring this with the Istio, the Grafana, with Kiali, with Jaeger. Okay, so I'm just bringing up some different tools here. So the Istio, the mesh dashboard, workload dashboard is the best one for this sort of thing. And let's go to Istio tutorial. Let's go into our recommendation version 2. So I can be looking at it here. Okay, how many 500s is it throwing out? None. That's good. You know, I can look at its performance characteristics here. I can also see here, if I can remember the password. I think it's just admin is the default. So, you know, I cheated here. But look here. This is the one we're working on right now, right here. 3 applications running, customer preference and recommendation. If I look at my graph, you can kind of see what the graph looks like here. You can see 1 and 2. And so 2 is green. 2's okay. But you'll see in a second that 2 won't be okay. We'll make 2 fail. So what happens if 2 is failing? You'll be able to see it there. Okay? So that's the concept of the dark launch. So where am I at now? Let's clean off our mirror. We'll go back to 50-50 load balancing. And this is new, by the way. This error right here, this no pointer exception, I got to figure that out. It's something new that just happened to me a couple days ago, and I got to find out what's going on. That's a new thing. Let's see here. So, all right, this is a fun one. Let's do this. kubectl exec it. I'm going to exec into this version 2 -c. Yeah, recommendation. Bin bash. So this is something you can do in regular Kubernetes. You can exec into a pod. You can SSH into a pod. And that's what I've done. I've kind of SSH'd into it. So I can say curl localhost 8080. Whoa. It's hard to type, talk, and stand at the same time. There we go. So you can see that's recommendation v2. That's the guy I'm messing with there. So my curl. But we have a little backdoor URL that basically is called misbehave. And it basically says, now you're a bad behaving pod because I have bad programmers and they did bad things. But if you notice, look what happened. So basically, version 2 of the pod, the version 2 pod, is always throwing out errors now, throwing out 503s like crazy. That's what that flag says. And our users immediately fell over to version 1. So that's kind of built right into this architecture. You know, Istio is basically trying to say, well, if you got one that you just deployed that Canary Deployment, and it's just bad. Let me see if I can just get around the badness. And it did that for me for free. So it's automatically retrying against version 1, right? 2 break, 1. 2's broken, 1. 2 broken, 1, right? That's all it's doing. And so let's see if we can have a little more fun with that. Let's leave that misbehavior in place. kubectl, edit deployment, recommendation v2. Let me open up the deployment. Again, any object that we're messing with here, you can open up with your editor. And let's say I want to actually roll out a second version 2. Okay, so I said replicas 2 now. You'll see a new v2 come into life. Assuming I hit save correctly there. There we go. So a new v2 come into life, and let's see how this changes things a little bit. I'm kind of curious because I've never run this particular test until myself. I thought, why not run it live with you guys? Let's see what happens. So the ability to scale things out, super easy. I could have also gone to the user interface, by the way, if I wanted to. Over here, I could have come to pods. I could have come to this one. What was this one called? The Istio tutorial. This, by the way, is a whole tutorial that we have. And you can kind of see what it looks like here. I can look at the deployments. So there's a UI for this. You can see there's 2 pods right there. I could change the pod count if I want to with a GUI. But notice what's happening. Okay, we have version 2 working here. This version 2 looks like it's working. And I don't see any responses from our other version 2, because the other version 2 is still misbehaving. So we're still getting our 50-50 load balancing, but some of the ones going to 2 have that error in it, but we're just working around it, right? Istio is automatically routing around it. And if I come back into my, so it's this one. Now let's try this. So this is the one that looks like it's OK. Let's go break it. Exec, IT, and C, recommendation, because there's a recommendation container. And we're going to talk more about this in a second. You guys are just getting the high level right now. I don't even know if you have type bin bash anymore. It's just kind of an old habit of mine. Let's see here. Curl, localhost, 8080. Let's make sure you got the right one. Yep, that's the Z1, 24Z6B that looks like the right one. Misbehave. Let's make it misbehave. All right. And notice everybody's back to version 1. Let me fix that flag. I call it the behave flag. So we're going to basically, this one is going to behave correctly now. All right, it's back in the load balancer. Let me go fix my other one. Okay, kubectl exec, IT, all right, C recommendation, make sure we got the right one, and bin bash. And again, I don't remember if bin bash is now optional. I used to have to type it, so it's muscle memory at this point. Curl, localhost, 8080, behave. Let's make it right. And I'll exit out there. And we should see now that we have there's that version 2. There should be the other version 2. And then we're all good again. Okay? So even that kind of behavior is kind of neat. I can come in here now and say kubectl edit, deployment, recommendation, v2, and I can change the replicas. Actually, let's not do that for now. All right, let's actually keep going here. Let's have a little more fun with it. Here, this is fun. Let's try this. I'm going to deploy a new recommendation, a new v2 recommendation. That's what this thing did here. And notice what's happening while it's being deployed. Everybody's going to version 1, while version 2 is getting updated. So version 2 is going through its rolling update, but version 1 is still responding to users. Okay? So again, this is kind of what I mean when I was saying earlier. If you want to deploy every Thursday at 9 o'clock in the morning, you can. And now, that may sound like craziness. How many people are still deploying like Friday night, hoping the software is ready by Monday morning? Anyone still doing that? Oh, man, you guys are like newfangled, right? So that's how I used to do deployments. When I managed an engineering team, an ops team, way back in the day, right, we deployed on Friday night, hoping we could get the software ready by Monday morning, because that's when people showed up for work. That was the most common pattern we ever had. Deploy Friday night, spend all weekend if you needed, right, to get the software working by Monday morning. That was the way we used to do business. But in this world, now in this DevOps world, you want to try to deploy like every day. Okay? You want to try to deploy all the time. And so what's happening with this model is if we're deploying all the time, we want to deploy actually in the middle of the workday when ops is ready and everybody's awake, they've had their coffee, you're not waking anyone up at 2 a.m., you're ready, your brains are on, and you can fix whatever problem is there. And so with an Istioized Kubernetes, that's essentially what I'm showing you now. You can do all this crazy stuff and just see if you can break it. And there are ways to break it. But here I have a version 2 now that's rolled out to production. And that version 2 is actually very slow, if you notice. 1 comes back quick. 2 is actually very slow. 2 actually has, again, the developer put a bug in that version. It just runs really slow based on what it connects to, whatever it's doing. And in this case, it just has a thread.sleep to make it easy. But it's just slow. And I can decide that for my SLA, keep in mind, customer calls preference, calls recommendation. I have a customer, a human customer who's waiting, and they don't want to wait. And if I come over here and look at my browser, if it's getting a version 2, see how long slow it is? That must, oh, and it's got an error. Good grief. I might have really injured it at this point. The application's not available. You know what? I think I killed it. kubectl, get pods. No, it still says it's running. Interesting. So that is actually the route. Could be my network between here and there is acting up a little bit. All right, there we go. All right, we'll have to check that behavior out. We'll have to figure that one out. You go away, Siri. Okay, but watch this right here. We have the slow one in place now. We got it up. Looks like it's up. So V2 is real slow. And I have this thing called the add timeout rule. Let's apply it. And let's look at it. And then you can see it's the recommendation timeout. Let's go in and look at that YAML file. Recommendation timeout. There it is. And notice what's happening here. It's attempting to talk to recommendation. It doesn't actually care if it's 1 or 2, but it only has a 1 second wait time built into it now. So yet version 2 is running at about a 3-second delay. It's messed up. It's having a lot of troubles. It's running at a 3-second delay. But I'm only waiting 1 second. And you'll notice, if you look at it here, still I'm getting some, I still get some timeouts back to my user. So in this case, what I have to do is I actually probably should increase my replica count of kubectl edit. Let's see if we can fix this real quick. Recommendation v1. Right, so one thing I have been running, I'm only running 1 of everybody right now, which is actually how you'll never do it. Right? You never want to run 1 pod of any one thing. You typically always run 2 pods. So let me bring up a second recommendation v1. And so here's there's my second v1 coming up, and that should fix my error. Because if I'm load balancing across, you know what I mean? You want to load balance across more than 1 pod. And so it's coming online. It's got to go 2 by 2, and hopefully that'll fix it. But you notice it's all v1 now, because we waited for 1 second for v2. We gave up on it. So these principles are all very, very powerful. Look, it's get another error there.
What happens if both deliver with the timeout?
What's that?
What happens if both services respond with timeout over the first?
Yeah, I haven't actually had a situation like that one. I'd have to test it to see what the behavior would be, right, in that situation. But it could be that I'm hoping it bounces to the other one. And if the other one's slow, timeout bounce back to the other one. At some point, though, it will come back with you will get a timeout error, and that might be what's related to this one right here. I don't think so. There's something else going on in my system right now that's causing that error, I think. But if we look back at our observability tools here, let's see what we got. For one thing, you notice we had a bunch of errors. Okay, so this is no longer performing 100% on version 2, and we got a bunch of red here on version 2. Version 1's green, but version 2 is red. So you would use your tools, your observability tools that are part of this infrastructure to basically see what the problem is. You know, you can kind of see that it's 100% error rate based on when I was looking. So that would be the way you would know if you're practicing the dark launch, right? The black canary, the dark canary. If you're practicing a canary type rollout, who is misbehaving? Are they poorly behaving? And how do I do something about it? And you kind of see right here that something bad is happening here. All right, let's see here. Let's actually fix that. Let's remove the timeout rule. Okay, now it's nicely going back to kubectl, edit, deployment, recommendation. It might get there before I get there. Let's see. And I'm curious to know what the image name is here. Okay, now that's the correct one. Okay. So it should roll back out a new version 2 without that timing issue in it at this point. Okay, but these concepts are, again, taking advantage of certain Kubernetes behaviors, but again, Istio layers on top to add these additional capabilities. How do you guys feel about that so far? Does that make sense? And we could spend a lot of time talking about these things. Let me jump back over here to the slideware, though. And when did we end? Does anyone know?
6:30.
Okay, we got about an hour then. All right, fantastic. So in this microservices world, right, you have the concept of distributed computing. You basically have to deal with the fact that A calls B calls C across a network. And you have to deal with the fallacies of distributed computing. And essentially what I was showing you with all that series of demos is what happens when things break. Because things will break if you put a network between two application components. In the old school of Java, right, you have a Java method calling another Java method, all within the same JVM. In this case, we now have stretched that out across a network, so one component calls another component through a REST API, as what we're all doing with Spring Boot, Spring Cloud. Right? You guys are following the Spring Boot, Spring Cloud way of doing things? You're putting a REST API between, and now you have to decide that how you're going to basically put that stuff in there. Right? How are you going to manage that? Because if you have a failure at one point in the system, you don't want a cascading fail all the way back to the users. And actually, if you notice the failures I was having earlier, customer was still responding okay, but preference and recommendation were not. So you can also decide at what point you catch the failure and still respond to your user with something that's okay, even if you can't actually make it all the way through. So the most obvious example that everyone talks about in this category of how you deal with this scenario, right, it's called a fallback position. You don't want the cascading fail, is Netflix, right? So Netflix under recommendations. So you might notice that if you ever log into the Netflix user interface, that you're not actually getting the same user interface you got yesterday. It's funny, because I do this talk so much, and I've been talking about this for so many years now, my wife actually will catch it happening and stop me and say, look right now, it just happened. And literally, it'll have not her recommendations. It won't be stuff that's valid for her. And she'll notice. And that's one of the situations that the circuit breaker concept is seen. Basically, they're going to give you generic recommendations. Or better yet, you'll notice that some of the user interface tiles that you normally get, like your favorite drama or your favorite comedy or whatever, for some reason the comedy one's gone this time because they didn't get those recommendations. Or better yet, continue watching. She likes the continue watching element, but sometimes it just doesn't show up. And tomorrow it probably will, or then wait another 10 minutes, it probably will. So those concepts of circuit breakers, especially in a read-only transaction like you see here and like you see in Netflix that's loading the user interface, it very well could be that you have decided that there's a fallback piece of business logic that determines exactly what to show the user when the other thing really did not run. So you guys familiar with the concept of circuit breakers and the concept of fallbacks? There's a really great presentation by a gentleman who worked for Sky over in London. And so his joke was very simple. He actually worked on the authentication mechanism for their pay-per-view type service, and I'm not actually doing this justice. So he actually had to make a business decision with the business. If, in fact, that if you could not authenticate that you were allowed in to watch the Manchester United versus Barcelona game, they had to default to let you in. Because think about it. You would actually cause riots in the street. If for some reason your service was down, it was an application built on Tomcat, it would often be overloaded on game day when everyone's trying to sign in to watch the game, and therefore the transaction had to respond with a positive, you're in, even if you weren't really valid if the service was down. That was the fallback position. He said it was fine, and we solved the problem for the football games. The biggest problem was when Game of Thrones was happening. Now they have a big problem with Game of Thrones because it overwhelms their service, and he's actually since refactored the service so it doesn't fall over. It was a Tomcat-based app, and now it's Rat Pack, I think is what he's using. All reactive architecture. In any case, you can see how Istio kind of fills in our capabilities here. It helps us with discovery. It helps us with resilience. It also has an authentication model and an authorization model, which we could show you. It has an encryption model. And then you saw some of the tracing and monitoring that we showed you over here earlier. You can kind of, let's see where those guys are at. Not that one. We can kind of look at more of these, but we don't have to spend a ton of time on these things. So where'd my Istio go? Istio system. I'm trying to figure out where my Jaeger went. All right, there we go. Here we go. So this is the tracing. Come on now. And where's my customer? let's see how this comes out. There we go. And the nice thing about the tracing, looks a little bit unusual, but sometimes it does. You can kind of see how long it takes per service, customer versus recommendation versus preference. And that's kind of a nice tool to have. If you have a distributed application architecture like that, tracing is very powerful. And so you kind of get that for free with Istio, right? So let's talk more about how Istio works underneath the covers. I kind of showed you what it does, but we want to make sure that you have some understanding for how it works. Okay? So before Istio, you would actually add all those same capabilities into your application logic. So this would be like your Spring Boot application with your Spring Cloud annotations. You basically have a starter or jar file in your app that gets bundled into your app that basically does discovery, and it's based on Eureka, or maybe load balancing based on Ribbon, or maybe resiliency based on Hystrix. All awesome, right? Cool stuff you can do. But now with Istio, you don't have to have that in your app anymore. You still can. You might still want to for other reasons that are all your own. But now with Istio, you can have the Sidecar Container. That's a second container living side by side with your container. And the way the magic works, it uses this thing called Envoy, by the way. And you can actually see the Envoy if we want to go look at it. Let's come over here. And let's make these windows a little bit smaller. Okay. Come on, mouse. And, oh, did I leave that editor open? Let's not leave the editor open. There we go. kubectl, clear, kubectl, describe, pod. Let's grab that one. Describe version 1. See, it says Istio Envoy, but you actually really see it right here. This is the configuration for this, what's called Istio Proxy. So the Istio Proxy is the name of the sidecar, right? The thing sitting beside your container. And you can see it's using the binary of Envoy. In theory, they could replace it with something else in the future, right? It's pluggable, but Envoy is what ships out of the box. There are different parties who are trying to provide their sidecar instead at this point in time. The only one I spent time on those Envoy, which is the default. But you can see here's kind of how the sidecar is configured, the path to the Envoy, what is its name, drain duration, discovery address, where's my pilot, which we'll talk about in a second, where's my tracing endpoint, there's the Zipkin tracing endpoint, what is my admin port. And what's kind of interesting about this is you can kind of say kubectl exec IT, the recommendation here, again, -c Istio Proxy. I think I did that right. Yeah, come on. All right. So I'm inside that thing now. Curl localhost 1500. Did I do that right? Yeah, that's it. But what is the actual, is it list? There we go. So what I am now, I basically did my little exec trick into the Istio Proxy, the sidecar, sitting beside my application pod. So the application pod has a JVM running in it. This Envoy thing is actually a C++ app running in it, but they're two separate containers living in the pod. Now, one thing to understand, too, about these containers, I can't really show you this. I haven't configured this properly. But if I could SSH into the actual node, this is actually a fun thing to show, but I didn't set up for it. I forgot about it. So I say get nodes here. If I could SSH into one of these nodes where my pod is running, and again, you can see kubectl, get pods, O wide. This will tell you what node, right? This pod is running on this node. If I could SSH in there, and if I did a ps-ef, you would see all these individual processes. You would see JVM1, JVM2. You would see the Istio Proxy 1, Istio Proxy 2. You would see them as individual processes on that host. So there's no magic here. They're still Linux processes. They're just Linux processes that have been highly constrained, right, with namespaces, C groups, and they're being managed by the kubelet, right, and the Docker daemon or whatever container runtime you have on that machine. So in the case of the new world of Red Hat, right, we were putting a different container runtime on those machines. You can still have the old Docker one, but there's also new ones now, right? And there's different ways to build your images, things like that. But in this case, you will see that I went to localhost because I exec'd into that thing. I basically said, hey, give me your list. This is the admin page for that guy. So I can come in here and interact with it a little bit. I've never had to do too much with it. The config dump can be sometimes interesting. Clusters is actually very interesting because that'll tell you exactly who can see whom within the overall mesh, right? That's what clusters means. So there's actually some powerful features here. But the concept of, let me go back to my describe. So this is what's living now in my pod. All this stuff that wasn't there before got added for me, either manually or automatically. Okay, so if you follow our tutorial, we show you how to do the manual injection of the sidecar. Let me bolt the sidecar on manually into my pod, and it's very simple. You just run one little command to say, I'd like a sidecar, please. Now, the way this cluster is configured, it automatically adds the sidecars for free. So you have that too. So it all, again, every cluster you touch is going to be unique, and this one has the add-on the sidecars for free automatically, which is kind of cool. Okay? That's kind of how it's set up. And you can see it has its own memory and CPU requirements. Notice the memory limit on the Envoy is 128 megs. So one thing that's kind of interesting is now with Quarkus, which can be like a 20 or 30 or 40 meg Java-based app, is smaller than the sidecar. So think about that for a second. The motorcycle is smaller than the sidecar. It's kind of funny to me. But we didn't ever think about this until we did Quarkus. Because with our normal Spring Boot app, Spring Boot is 140 meg or whatever, and it's bigger than the sidecar. But then you have Node.js or something else that's small, Quarkus, and now you're like, sidecar is actually bigger than the motorcycle. All right, so that's the sidecar concept. And when I don't think I have the image here, but you guys know what the sidecar is, right? That's why it has the name sidecar. Sidecar motorcycle. Right, this is where the term comes from. And actually, here's the image I like using. The difference is that the sidecar, in this case, the difference in the Istio sidecar, Istio Proxy it's called, and implemented through Envoy, is it can actually take over the handlebars, it can take over the gas pedal, the brake, because that's what you just saw in the demonstrations I ran. So it's a very special sidecar. It's not a dumb bolt-on, it's a smart bolt-on. Okay, and we'll talk about what that bolt-on does here right now.
And is this still a Red Hat product?
It is not a Red Hat product per se at this very moment. Give us about 30 more days.
Okay.
Now, so the way the Red Hat model works is so Red Hat basically contributes and interacts with all these open source projects. We have over 1 million open source projects that we track, like literally 1 million. Istio is one of those, right? My team and others work on Istio specifically, and what we are doing is we're going to provide official support for it. So when you say product, what that mean for us at Red Hat, that means official support for it, right? So that you can have a contract and an SLA with Red Hat, we'll fix bugs, etc. And that is any moment now on that side. It's not at this moment. There is a tech preview version you can add to your OpenShift cluster. It has to be an OpenShift 4 cluster though. But we will offer official support for it on OpenShift 4 any moment. And I'm running the soon-to-be product enterprise version.
Well, as I understand, Istio is a Java-based product, right? It's
oh, no.
Quarkus.
No, Istio is, well, it has nothing to do with Java. That's actually, yeah, so Istio has nothing to do with Java, right? Istio is written in, there's two pieces to Istio, Envoy, C++, Istio itself. And so if you look here, so here's Envoy. It's called the data plane. So this is what's involved in your transactions is the Envoy. That's written in C++, okay? Then you have the management of those envoys, the pilot, the galley, the mixer, the citadel. That's Go. That's all Go code. So that's the distinction. So here's one thing. Envoy actually as a tool has been in production with the Lyft company. They're also run by American Express and a bunch of other people. So Envoy can be just run on its own. And it does all this kind of reverse proxy stuff for you in a kind of a magical way. Like basically you can manipulate Envoy with its own set of rules in its own unique way. What you're doing with Istio is managing all the envoys in the mesh. So basically, instead of going in each envoy and saying, let me tweak your configuration, tweak your configuration, tweak your configuration, you're saying, hey, pilot, Istio pilot, let me tweak the configuration, and pilot finds all the envoys and tweaks the configuration. So that's really the point of Istio, right? It's the management or control plane for the data plane, otherwise known as Envoy. So you kind of see right here, there's a distinction. The galley does a validation of the YAMLs you're deploying. Pilot, of course, is basically the API endpoint, the configuration for those routing rules. Mixer actually comes in two forms, telemetry and policy. It manages things like quota and gathers the observability data for telemetry. You can also do access control list. You can do other policy enforcement things within Mixer. And then Citadel gives you your certificates for the MTLS. So that's how you actually invoke MTLS on the backplane so you can have encryption over this wire. Okay? And you kind of see what it looks like here. It has HTTP 1.1 support, HTTP 2, gRPC, and TCP with TLS. And if I come over here now and look at these guys, let's actually go to the UI. We'll come here. Let's go to not networking workloads. Let's go to pods. So I'm in the Istio system namespace. And there's Elasticsearch. There's Grafana. There's the Citadel. The egress gateway. There's also there's Galley that we just mentioned. Ingress gateway, which we aren't using at this moment, but we can be. Pilot, policy, sidecar injector. Remember I said you can automatically add the sidecar. This is the guy who automatically adds the sidecar. Telemetry, the Jaeger thing we've been talking about. We showed you earlier. Several Jaeger agents and collectors. Kiali. So the user interfaces I showed you. Prometheus, right? All here. These UIs also. So like there, Grafana. So those are all pods running in this thing called the Istio system. If I come back over here and say kubectl get pods in Istio system, you can kind of see them running right there. So that's what we're talking about. So the Istio itself is implemented as a series of pods that are out there doing all this magical work for us. So that's another thing to understand about anything living and breathing in a Kubernetes cluster is the things that are running are typically pods. There's older ways to do it that you shouldn't have done it, but everything should be a pod now. So here's kind of my point. I've deployed customer preference and recommendation. That's all I've done as far as business logic goes. If I say kubectl get pods, -s all namespaces, let me see all the pods in this cluster. You can see there's a bunch of them. Okay? So I can come up here and see it at the top level, projects, and actually like just pods, all projects. So project is the word for namespace, and OpenShift is the same thing. But 200 running pods. I run cluster preference and recommendation. I got another 197 other things running in my cluster. What are those for? And that's all the other infrastructure that I want to have all this Istio capability. That's what we saw earlier with the pilot, the galley, right? And then I also have my Knative serving, my Knative eventing, my Knative build. Now, I don't actually have build here in this particular cluster. But see, there's a Knative serving component. OpenShift itself, OpenShift capabilities are built on top as pods. When you get a raw Kubernetes cluster, you'll see a bunch of pods already running inside a raw Kubernetes cluster because it's got pieces of itself running on itself. I know that sounds kind of crazy, but the point, this actually was a big transition over the last few years where basically the Kubernetes stuff should run on Kubernetes, if at all possible. And so you basically, what you think of as a cluster is often just a bunch of other pods running in other namespaces, like this one. So there's the demo 2A, the interconnect there. So there's the OpenShift API server, Franz. That's the thing where we built the, remember when we built the Kafka cluster? Well, I have another one here called Franz. So there's Kafka. So I do have some of my own stuff here, but a lot of it is not mine. Right? It's also the user interface we're interacting with right now. This UI is running as another set of pods on top of the cluster. So that's kind of a neat thing in general, right? You can kind of bootstrap the cluster inside the cluster. It gets kind of confusing. It's a little bit like Inception. If you guys remember that movie, yeah, it gets a little bit weird like that. Okay, let's jump back over here, though. Keep talking about these things. And you guys can keep throwing questions at me. So we kind of ran all these demos. But I want to show you some more stuff, right? So we showed you the Kafka, right? We showed you how to sprinkle transactions across all these different clouds, things like that. Now we showed you a bunch of Istio stuff. We can do more Istio if you want. We can try doing different configurations, different settings. Let me double check something over here. If, in fact, you want to configure your own, you can do that with Minikube here. Get namespaces. I don't know what I have on my Minikube. Yeah, I don't have much here. Get pods. I just built this Minikube a little bit ago. I haven't looked at it yet. in a real significant way. All right, you can kind of see even on Minikube, which is the lightest of lightweight, there's already pods that I'm not responsible for that it's using to manage the Minikube cluster. Okay, so even Minikube already has some pods built into it that are, for instance, storage, which makes some sense. I don't have the ingress turned on, but you would see an ingress pod if that was the case. etcd pod, which makes sense. You've got to have etcd, otherwise you don't really have a Kubernetes without an etcd. Core DNS, right? You want some basic DNS support. But let's do, I have a script over here. I like scripts for things. But let me go ahead and deploy to install Istio Minikube. I'll go ahead and install Istio into this Minikube. So it's not here yet. kubectl get pods -n Istio system. Yeah, it's not there yet. There it goes. You saw some CRDs blow by. And now, so if you're watching carefully, there's a bunch of, so there are some CRDs. Apparently I had, well, actually I think that's in their script, funny enough, that they have some CRDs declared twice. You don't have to do them twice. So, but there were some CRDs that were added, a bunch of service roles, service accounts, right, for setting up security config maps. So there's some CRDs right there that are added. You can see that now those pods are coming to life inside the Istio system. So based on the network performance between the internet and my laptop, it's now going to download those images and start running those different pods right there. Okay? So, I mean, that's what it takes to install an Istio into an existing cluster is simply you got to poke at the right YAML, and that's all it is. So you can go, oh, look, some of it's going running pretty quickly. Not too bad. Oh, those are jobs, I think. Yeah, those post installs are jobs. So jobs you'll see run and then not run. See, it's completed now. So those are actual jobs, but you can kind of come over here and say kubectl get deployments and Istio system. You can see there, that's the deployments, right, for pilot, policy. So Mixer is policy and telemetry. It used to be one pod called Mixer. That's where the name Mixer comes from. But now it actually is technically two things. So they split it out. And by default, policy is off by default now. Telemetry is on by default. And that's because policy does incur a fair bit of overhead as it tries to apply specialized rules, like what traffic is allowed. Before we leave Istio, if I go to my Istio, I just want to show you a couple slides on some of the other capabilities so you're aware, and then we'll move on to the Knative piece. This is the 3-hour deep dive on Istio by itself, so it has a little bit more content in it. And also, I let people do hands-on with all this stuff as well. There's the dog, see? It's all done through CRDs, blue-green, canary, description, right here. Okay, so a couple things. This is no longer true, but it used to be egress was blocked by default. It could be in your cluster, it's still blocked by default because your ops team, your architecture team decided to block it by default. So just mentally be aware that if for some reason you can't get out of the cluster to the outside world and you just use Spring's REST template or some other REST API to make the call, it might be that egress is being blocked because that was a thing for Istio. It's now turned off, but for some people it's still turned on, okay? I think in my case it is turned off, and I can double check that real quick. Here's the way to test it. In case you run into this, kubectl get pods. Okay, so let me jump into this pod again. It's a simple test to find out if you're being plagued by this issue. Just be aware of it. So I'm jumping into the recommendation pod again, and container recommendation in this case. Bin bash. All right. And let's see, curl http bin.org. Let's see. Oh, it worked. So we're not on this cluster, not blocked by default. Egress is allowed. If it was blocked by default, you get a 404 back. And that's true of all your code too. Your Node, your Python, your Java code would get blocked. So that's something you should just be aware of. And so I need to say, sometimes. It depends on some factors here. So they've tried to turn off the by default. It's actually a very important security position. In other words, it was a good reason why they blocked it by default. If you're a hardcore cloud person, and how many people actually have their infrastructure running on Amazon or Azure or Google at this point? Okay, so you have some infrastructure there. If depending on the world you're living in and how hardcore you are about the cloud, it's very likely you have a Bitcoin miner leveraging your resources to basically mine Bitcoins. But if they can't phone home to get their Bitcoin back, they're not really winning. They're just using your CPU cycles. You guys never heard of that? It's like a thing. It's true of any data center. It's not, I'm picking on cloud providers. But yeah, the Bitcoin miners have been very, very clever the last several years. They figured out how to get into your infrastructure, and you don't even know they're there. They're just running off your CPU. But as long as they can phone home, they can get their Bitcoins back. It's kind of a thing. It really is a thing. And I say that because I know people who go out and expunge Bitcoin miners. That's their job.
I have to change the...
Oh, I killed batteries already. Was I getting quiet? It's hard to know. I'm so loud. Yeah. Okay? But that concept is important to understand. Also, when it comes to other security posture that's available with Istio, if you guys have this scenario, and you guys tell me, Sabre folks, you might have this issue. Okay? So in the case of a big bank, this is where I discovered this concept. They have at a big bank, they'll have a customer success team, if you will. Like there's a specialized group of in the organization, people responsible for customer happiness. And they might have their own programming team who helps them build their custom apps and APIs. They take care of the mobile API, the mobile apps, right? They want customers to be happy. But then at the same time at the big bank, they also have people like you and me who have our checks deposited from our direct deposit into our bank account, and there ain't much money there. And then you have people with $2 million in the bank. They get a different customer success team, okay? They get a very specialized customer success team, and they actually have their own IT infrastructure. I know that sounds kind of crazy. In other words, you have customers that are so important to you that you're going to give them some special treatment, special account reps, special infrastructure, special software in some cases. So I picked on Sabre because, you know, you might have some of those issues, but any big company with big customers has that issue. And so what happens if you're looking at your services and you got to think about all your pipelines, you got to think about all those pipelines and all those teams. So the reason this matters is I'm going to have one team responsible for these microservices through their pipeline, a different team responsible for these microservices, and I want to be able to manage all that. So how do I secure this? So you can put encryption amongst these services, so you can encrypt over the wire. And I don't have it set up on this one. We could try it, but basically you'll see that all the traffic is clear text by default. But with Istio, you can say flip it into MTLS mode. Now it's all encrypted over the wire, even amongst the pods. Okay? Because if I have team 1 who can deploy to the same cluster team 2 can, I don't want team 1 to see all the traffic from team 2. They're dealing with special customers. So in the same cluster, I can have MTLS encryption of the calls between pod 1 to pod 2 to pod 3. Very powerful feature, actually probably the most popular feature of Istio. People are very excited about that one. Access control, again, we'll talk about that in a second. And then you can do JSON Web Token and RBAC. And that's all part of our concept there. So here's the encryption concept, right? You don't want the eavesdropper listening in because they have a pod. They can eavesdrop. And so it's in our documentation, and I show people this. I have a script for this. So basically, you can listen right in, okay, and see the traffic going through the network. Access control. This is another good idea. I want customer to call preference and preference to call recommendation. That is the only valid call path for my microservices. I don't want recommendation to recursively call customer. That might just be a rule that we have in our business, okay? Because that just gets weird. It would work. It works fine, right? But we just don't want that. So therefore, you lock it down. You can basically lock down the customer direct to recommendation with bypassing preference, and you can lock down the recommendation to customer. You can lock down the preference calling customer, you know what I mean? In other words, you can lock down all the paths you don't want for your customer invocations. So that's another thing that's actually pretty powerful. And then this one thing that you'll see, and actually we've been changing our documentation on this, it's called Keycloak. It's a JSON Web Token. God, I'm so old at this point. Google Web Toolkit. Anybody remember that? Every time, because in Europe, you actually call this GWT. In the US, we call it JWT. But in Europe, it's GWT. And the reason that's funny is because GWT is something completely different. It's called Google Web Toolkit. This is JSON Web Token, right? It's the token, so you can basically carry it around, and then you're authenticated. And so the concept of Keycloak being your authentication engine, giving you the JSON Web Token. And so we had docs on how to configure that and use that with Istio. And that's kind of just a high level, all right? And also, they made a bunch of changes with 1.0. So it was called a route rule. So if you see old content, like my old version of the book, you'll see route rule and destination policy, egress rule. And in the new version of the book, the second edition, you'll see virtual service, destination rule, service entry, gateway, things like that. So they changed terms. So I want to make sure you have that, but let's kind of keep going here. Okay? So let's talk about one new thing besides microservices. I like this quote, be happy but never satisfied. So you're thinking, wow, I've talked about way too much stuff already, and I'm already tired, and it's the end of the day, my brain is fried. Let's fry it some more. Okay? Let there be functions. So in my mesh of services, I actually don't want microservices. I want these concepts of functions now. I want to be serverless. Because microservices is so old school. And actually, for those people who have been paying attention, microservices is a 2012 architectural style. It is literally 7 years old at this point in time. So the stuff I've been talking about, it's like 7 years ago, Netflix showed us how to do that. Literally 7 years ago, they showed us how to do it. That's when they open sourced all the parts to it and said, this is how we do it. And that's when Amazon came out and said, oh, yeah, that's how we do it, too. And all the unicorns were like, what are you talking about? Amazon came out and was like, we've been doing it for 8 years from 2012, right? We did it back in 2002, 2004. So it's a funny conversation. So we in this, the world we live in, it's like, hey, it's 2019. We're just now starting this architecture, yet the world has moved on. So what about event-driven or serverless architecture? And the key thing to understand in this architecture is there a service I can use versus having to build it on my own? In other words, it's really serverless because of backend as a service or software as a service. And kind of explain that. So I need HTTP traffic in and out of my overall application. That is known as an API gateway now. It might be Nginx, it might be HA Proxy, it might be some other derivative of those things, or it might be the Amazon API gateway, it might be the Google API gateway. But you don't want to have to build Nginx on your own. Why write that code if you don't have to? Or better yet, has anyone here actually tried to be an Nginx programmer? Anybody actually built their app in Nginx, meaning Lua, the Lua program? So you write code in Lua, right, to extend Nginx to give it all kinds of cool capabilities. You don't really want to do that if you don't have to. How does that add value to your business? It's kind of the point. So why not get one of those out of the box? Don't build one on your own. SSO, I just showed you Keycloak as an example. I mentioned that if you want an open source SSO, go get Keycloak. You can run it on your own infrastructure. Or better yet, just go get one of the cloud provider SSOs. Don't build that on your own. You can issue JSON Web Tokens yourself. You can write all that logic yourself, but you don't have to, right? Especially for different users, and also you want a federated login. With Keycloak, you can basically say, make it the GitHub login, the Twitter login, the Facebook login, and all that. You could write all that code yourself, or you could just simply use it. Storage is a great example. Storage was the very first service on the public cloud. You guys don't know that, do you? Everybody probably thinks EC2 was first. VMs for rent, but it was actually S3 that was first. So if you think of the very first, what's notable as a cloud service was S3 from Amazon. And so therefore, why would you want to build your own content delivery network? Why would you want to build your own globally distributed storage network with data centers around the globe when you could just put your files up on S3 and then you're done? Better yet, if you have an application that uploads files, like through a mobile application, you let your users take photos. Let's say it's an insurance claim, they take a photo of their broken car or a PDF or whatever. That gets stored on S3 or for almost all of us. You guys are probably using S3 in part of your infrastructure for your applications already, right? Anyone using S3? And if, you couldn't admit to it though, right? No, we're not doing it. Cache as a service, database as a service. I make this point because I know Java teams. I've been in Java world for, 20 plus years at this point, since 1997. And guess what Java people love doing? They're like, I can write my own database engine. Why would I want one of your guys' database engines? Oh, I can write my own message broker. That's right. So, and we used to write our own MVCs. We probably still do. You probably still have a project inside your company that has their own model view controller framework for Java people because you can. But this new way of thinking is you don't build it again. You use what you can, right? So you only fill in the gaps with your big old microservices once you've actually acquired the pieces of your infrastructure that you can just use. Ideally, you're using a messaging broker, not building a messaging broker. You're using a caching service, not building a caching service. You're using a database service and notification service. And then here's the trick. The big components are your microservices. Those are the big ones. But then you hook these things together in an event-driven way through the concept of functions. This is a new goal. Now, I'm not saying anybody's here yet. The only real team that's here yet is Amazon and Lambda, right? They got all this. No one else really does. We don't have it in the Knative universe. I simply paint this picture because this is where we got to go from a Knative standpoint if we truly want to be successful with this new architectural pattern. you, of course, will consume this as a user, right? Your users, your business-to-business users here, like my little factory, your desktop users, your mobile users are going to communicate directly with the gateway, the storage, the SSO, and maybe even push notifications. That's how the user interacts with those different APIs. But what's behind here are event-driven functions which hook and wire the pieces together. That's kind of the goal, all right? This is really crazy. For Java people in particular, you're like, wait a second, are you telling me my component is not always on? Right. It's a fundamentally different way of thinking, okay? So let's see. I like this quote. You must be shapeless and formless like water. That's great, okay? All right, so let's kind of show you this Knative piece. So Knative comes in 3 components: build, serving, and eventing. What I was describing there is more serving and eventing. If you notice, the build has a red line through it right now, because a lot is changing in the world of Knative build. As a matter of fact, Knative build became so popular on its own, it's actually graduated to its own special project. So that's why there's still build elements of Knative, but a lot of it got moved on to a whole new project, and we think the rest will move on soon. So you might be Knative will end up being 2 things, serving and eventing, and Knative build becomes something called Tecton, which I have a slide on that later. Okay, but the goal of Knative was basically to take everything that we see in the Kubernetes platform and Kubernetes ecosystem, where people were building function as a service and serverless architectures on top of Kubernetes, and we wanted to bring the core key primitives of all those platforms back into its own separate project. That was the goal that Google had when they created the Knative project, are these common things that everyone needs, like scale up from 0 and down to 0, you know, they must have liked it, that you could do that within the context of one single application instead of figuring out one of the 15 other vendors to choose from. So that was really the goal. So the real interesting stuff here is to scale to 0, because if there's no pod, there's no memory. The computer shut down. Your Java code's no longer running. There's no pod. And that might be okay, because here's the real thing, and this is hard to describe, and I probably should figure out a different way to visualize it. In the old world we've always lived in, remember I said I deployed on Friday night, had to be ready by Monday morning. I talked about the fact that you deploy every 6 months or every 3 months like clockwork, and that's what you want. So what we used to do is we would basically say, oh, this application, based on our expected user load, you know, and by the way, we know the user load peaks on Monday at 9 o'clock in the morning. That's when all the users kind of sign on and start really querying the database or whatever. But, you know, after Monday morning, it kind of drops off a little bit. And, you know, it peaks again on Wednesday morning, because that's when they all sign in again. And then kind of drops off, and it's dead on Saturday and Sunday. Almost nobody works on Saturday and Sunday, and therefore, that application is very lightly loaded. But what we do in that scenario is we buy enough hardware for peak. That's what we've always done. We think that we need 18 CPUs and 84 gigs of RAM to support peak. And therefore, we buy the hardware for peak. That's just the way we've always lived. And the good news is Java supports that case nicely. In this new world, we're probably thinking, OK, I need to be able to scale out for peak. But if it's not peak, scale back. Let that memory and CPU go to other folks who might want to run their jobs now. And within a single cluster, this is what you can do. And this is what Knative's goal is trying to achieve. So on Saturdays and Sundays, scale it down to 0. No one's using it. Why is it even on? And you can also in Knative decide, OK, 0 is actually too low for me. I don't feel good about that. Get it down to 1 or 2. OK? So in other words, you can decide what your floor is. By default, Knative is 0. No one's using it. Shut it down. OK? So let's try to show you what that means in practice. So let's see here. I have this little demo thing. I showed it in my Kubernetes, my Quarkus talk. God, I've been doing too many things. Kubernetes side by side. Let's see here. All right, watch. kubectl get pods. Let's see if there's anything running. OK, no pods, no resources found. So it looks like I've got nothing running, because I have nothing running. But if I come over and say kubectl get deployments, I think I already have some deployments. I actually have a Spring Boot deployment, a Node.js deployment, and a Quarkus deployment already running. So I have deployments, but no pods. I have 0 of 0 ready. In other words, the deployment can go to 0 if you basically say, hey, deployment, make yourself 0. And it'll go, OK, replica set, make yourself 0. All the pods get shut down. You could do this manually. OK? In other words, you could always go in and say, make everything 0 and scale everything down to nothing. But with Knative, it does it automatically and then also scales back up as load comes in. So let's apply a little load. So kn burst, all right. We're going to apply load to the Quarkus app. So it's going to send in 40 concurrent users. And based on the 40, it's going to try to store 4 pods, because I've configured it that way. You can decide what the ratio should be. But basically, in a panic attack, oh my God, 40 people just woke up all of a sudden, hit the button. I'm going to try to get somebody online to answer these 40 users right now. And it's growing as hard as it can. And you can see it's got 2 of them up, third one up, and is the 4th one going to come up? Yeah, you know, but it's basically doing that in real time. So kubectl get pods, O wide. Let's see here, I'm curious to know. You can see they're on different nodes, worker nodes, so it's going out across the cluster, right? Run, 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 run. We're in a panic. Bad things have happened. Get pods. And here's what's kind of funny about that. Okay, I got 4. And I can come in here and run this again. I can throw a bunch of load at it again one more time. But what's kind of cool, you know, now it's responding super fast. It actually held the traffic momentarily as it tried to get the infrastructure stood up, and then lets the traffic through as the infrastructure comes online. And notice what's happening right now. Even though I'm still hitting it like really hard, it now realizes, 40 users, I could handle that with one of these pods, which is true, right? But I've configured it so that it goes into more of a panic and tries to say, oh my God, there's a whole bunch of traffic. Let me start up a bunch of pods just in case. So this concept, so 4 might be my peak, but I don't have enough load right now to justify those 4 things being online. All using memory, all using CPU. So if I come in here now and say, let me just keep a polar, this polar is just going to be a single user every a third of a second, half a second, whatever I got it configured for. It's just, you know, curl command. So because a single user is coming in, or at least a bit of traffic is coming in, it'll keep the pod alive. If I stop the traffic to this guy, and this actually could be it's on the public internet too. If I give you the URL to it, you could be touching the same thing. But your touches would keep it alive. But what happens if nobody touches it, in 90 seconds it scales down automatically. That's the default in Knative. Wait 90 seconds. And it's 90 seconds plus some leeway, right? It might be 100 seconds, 120 seconds. I've never seen it go up to 2 minutes, but it depends on a lot of factors. You know, because it's also got to get CPU to make this decision. If you've completely wasted your cluster, and I've done that before, like I've completely overloaded the thing, it might take a little while to get to this logic. But it says, you know what? No one's touched this thing for 90 seconds. Let's just shut it down. And so if you're watching, get deployments again. It helps if you spell deployments correctly. Watch, kubectl get deployments. And you got to say get. All right, see right there, it says 1 for 1. And if we wait about, I don't know, probably 30 more seconds or so, we'll see that go. It'll basically say, hey, deployment. No one's touching it. Your go to 0. Replica set goes to 0. Pod gets terminated. Basically, it kills the pod. And so we can wait a little bit longer, or we won't, because I want to show you Node.js. So here's the kind of thing that's cool about this. It works, all this infrastructure we're talking about with Istio and Knative, all this capability works the same for any programming language. Netflix OSS, which gave us the microservices concept, is only Java. This works all across anything. I have .NET applications, I have Python applications, I have Go, I have Java, I have Quarkus Java, I have Spring Boot Java, right? It doesn't really matter. So here's my Node.js coming online, and there's my Quarkus one being terminated now. Okay? Let me keep the polar running on this one. You'll see the same behavior here. It'll be like, hey, I panicked. You sent me a bunch of load at me, but I got 4 started. I don't really need 4. You'll see it starting to shut down those 4. Let me bring this one back up. So even my single user activity will bring another Quarkus back online here. You see that? So it's coming back to life now that it got shut down. And so here's why this concept matters. You may not want this for your application infrastructure. You may not want a situation where any user has to wait for anything. So you can actually tell the Knative, your floor is not 0, your floor is just 1. Okay, so you'll notice it basically started killing these guys, and it's taking us down to 1 because there's a single user. If I shut down a single user, it goes to 0. But you might decide, you know what, just assume 1. You might want to say just assume 2 because I always want HA, right? High availability. but at peak time, I need 10 to handle the load. And with Knative, it'll do that. So by default, Kubernetes will scale, auto-scale, your application or your infrastructure. And actually, one thing that you can see, like you can we have a user interface in here that's kind of cool. Like if I come over here to my compute, machine sets, this is new and actually in OpenShift 4. But you can kind of see, this is the number of worker nodes I have. I have 2 of these running in this availability zone, and I have 1 of these and 1 of these. I can come here and change this. I can come in here and say, I need another machine. And that's going to add a whole new worker node to the cluster, right? And that takes several minutes, though. It basically goes to Amazon or Azure or whatever and provisions a whole new thing and boots it up. That could take 10 minutes or so, depending on what region you're in. That kind of auto-scaling, if you will, has kind of been part of the Kubernetes ethos for quite some time. This concept here, it's based on user traffic. But you see the distinction? It's not CPU load or memory load. It's based on literal transactions. That's the real distinction what Knative has done here. So you had some of these capabilities before.
So this is also perfect for learning, how to use the clouds when you have to pay for the service. So if you are using it, it will stand up, and if you finish, it will go down.
That's a very good point. You could still do those kinds of things within your own cluster as the cluster administrator. You could do it with Knative or without Knative, but with Knative, it kind of is automatic, right? That's true. Because I don't know if you guys have worked on the cloud for learning purposes. I do, right? I spend time on Azure, Google, and Amazon, and I invariably get a bill at the end of the month where I'm like, I left that VM running all month? Oh, crap.
Yeah, I'm trying right now to figure out how to do this, and not pay much.
I'm looking at this now. Let's see. This is my, what is this one? This is my Node app. And this is my Quarkus app, right? So if you look here, Prometheus has this kind of clever feature. We've documented this. This is our docs as well. You can kind of say, what is the container memory of the Node app or the Quarkus app? Send a namespace side by side, and the container is called user container. When you use Knative, you don't name the container. In Istio, you name the container recommendation, customer preference. In Knative, you don't do that anymore. It's called user container because it's kind of wrapping it its own way. It should also be noted when you deploy a Knative service, let me open this up. The Knative service declaration is slightly different. Like look at this one. All right, notice it's called service also, but it's not a Kubernetes service, it's a Knative service. So now we have service overloaded 3 times today. You have the regular Kubernetes service, you had the virtual service in Istio, and now you have the Knative service. And there are 3 different things. And they have 3 different sets of behaviors. I think that's just wrong. But, I didn't decide these things. And what would you call it? It's still a service. So this is, in fact, think of this structure right here as your app. It's actually easier to work with than what you've had before. So what you had before was a deployment. Well, you had to build your image, get a deployment, and then you had to have a service. And that does the old, normal Kubernetes way to do it. And then you had the virtual service if you want to manipulate the routes and things like that. And now you have this Knative service, which you don't have to have a deployment for. You get one for free. You don't have to have a service for. You get one for free. And you get all this other infrastructure automatically behind the scenes to deal with this auto scale up and scale back. Okay? But you basically are interacting. And this is also, again, done through a CRD, custom resource definition. It's a custom resource called service for Knative, just like virtual service and Kafka. Here, you can see the auto scaling target here. That is how I got the 4 pods out of 40 concurrent users. So in other words, by default, this number is 100 out of the box. It assumes that any given pod can handle 100 concurrent requests. That's Knative's presumption. 100 concurrent requests for any pod. You know that if you got a badass JVM app set up correctly or a Node.js app, you can handle 500 users, 1,000 users. And you might want to tune according to that. However, if you're living in this function as a service world, you know what the number is? 1. If you're dealing with Amazon Lambda, that's 1. Okay? Your concurrency factor is 1. 1 request, 1 pod springs, well, not a pod in the case of Amazon Lambda, 1 container springs to life, runs your function, and goes away. Lasts for maybe 2 minutes, lasts for maybe 5 minutes, has so much memory that you find if you use Amazon Lambda. So that concept, you might think the 10 was too low, but in that world, it's actually 1. So I also do presentations where I just make it 1.
So It actually runs kind of a pod inside the node, right?
It is a pod, right?
So,
you saw the pod, like there's my node pod.
Yeah, so what happens when we hit the node limits? I mean, like when we overflow memory to CPU.
Well, you're not supposed to do that, all right? You're supposed to have the limits, and you can see those limits here. You can see I put them here. You're supposed to always specify your limits, and if you don't, your cluster admin should do it for you if you're a bad developer.
No, okay, we have like, for instance, two CPUs for the node, right?
Right.
And for the code on Knative, we have like 0.1 CPU.
Right.
So we can start.
This is less than 0.1, yeah.
Yeah, we can start 20 Knative pods. What will happen when we need the 21st one?
Right. So do you guys understand the question? Because it's actually a very good question. So important. I'll try to repeat it and see if I get this right. All right, so if you look right here, I have actually said I need 50 megs of RAM. I need 0.01 CPU. That's actually, so this number goes to 1,000 representing a whole CPU. That's one whole CPU, right? So a tenth of a CPU is 100. So this is a tiny little piece of a CPU, right? So it's less than a tenth of a CPU. So that's all I believe I need, and these are purposely low so I can run these demos easily because I only have so much. I can run all this on my Mac also, right? So I try to keep things small. And I mentioned this because if you have larger apps, then you can't show the scaling out and stuff like that. So when we run a class with students on their laptop, you'll see it happen a lot. People run out of resources. But that's exactly what he's trying to ask for. What happens if I have a node? I have my nodes, my worker nodes, and it already is kind of pushing the maximum on CPU usage and memory usage. And we have like, I'm just going to show you this. Where is it? Right here. I'm just going to pop this open if I can real quick. I don't know if I've run this yet. Yeah, let's see. And my Kubernetes cluster resources. So I'm actually doing really good right now. Look at this. I got only 11% committed on the request side, 20% of my limits. I'm only 19% on memory, 10%. And often when I purposely scaled this cluster out for today's demo, I normally, if you look at some of my clusters, they're at 101, because you can over-allocate, right? You can basically have 90% of your resources usage or 110% of your resources usage. So that if you have a situation where you have a cluster that's already maxed out, or at least a node that's already maxed out, and you ask for get this thing to scale up from 0, it won't. Okay? You'll see pending, which is the dead giveaway in Kubernetes land to say, I must be out of resources. There's not enough CPU. So the way the pending thing works, and we could simulate it here. I actually have had that happen to me. Basically, it's going to take your request, and it's going to say, hey, any node. And so if it's only one node that's overloaded, it'll ask the other node, you can absorb this request, and the other node might go, yeah, I got 50 megs of RAM. I got less than a tenth of a CPU available. I'll let him join me. And so the scheduler will basically map it over to the other node. But if all your nodes are maxed out, you will see pending. Right? Pending meaning I got no place to put this thing. And then of course you'll see you'll start noticing in your monitoring tools. You won't see that alert here, but you will see it here. You'll actually see you got things pending. You're out of cluster resources. You'll see that list here. I'm not pushing this thing too hard, but if I scale the cluster down, I've actually used very small clusters just for the point of showing that. This one's actually a very beefy cluster because I've been practicing with larger nodes. Like those worker nodes are I think 16 cores each. I do have some. I've set it up with 2 core each, in which case you can run that out of gas really fast. Okay. But does that answer the question? And is that help discussion helpful to, yes, sir?
Is there a way, a possibility to map Canary container to Lambda?
To Amazon Lambda?
On the cloud?
For Amazon Lambda.
For Amazon or Google.
Right. So, and I make that point because Lambda is a term that shows up a lot. There's the Java Lambda programming, right? There's the Amazon Lambda.
I mean, this Lambda serverless.
Right. So for Amazon Lambda, the answer is no. Right. Amazon Lambda was an architecture that came to be a long, long time ago, long before there was a Kubernetes and long before there was a Knative, basically. Right. So They're not using Knative or Kubernetes for Amazon Lambda. They have their own thing that we don't even know how the magic works at Amazon. And there's no way for you to take your Knative service, this declaration right here, and say, make that run on Amazon Lambda. However, all right, what we are working towards is, if you look at the image here, see the image? That's my Java logic. Is there a way to make my Java logic portable from this Knative world to the Amazon Lambda world? And yes, that is being done. So your actual code can be portable to Amazon Lambda, to Knative, and vice versa, but not necessarily the declaration of the thing. That's going to be unique per platform, right? So the Google Cloud Function is going to be different than the Amazon Lambda, which is going to be different than Azure Cloud Function. And here's one thing that's kind of cool. If you're an Azure shop, Azure has open sourced their Azure Cloud Functions, and we have made it work on this. We worked with Microsoft in partnership to actually make that work so it actually can work on Azure and on-prem on your OpenShift together. Same code base, same declaration.
So actually, if you're running out of space on nodes, it can span the other Knative application on Azure functional.
Well, it won't do that by default. You know what I mean? It won't go cross-cluster, and there'll be two different clusters. But at least your business logic is ready to run there if you need it to. And you'd have to have a global load balancer that sits across the two clusters. Maybe your global load balancer is over at Amazon, and it's basically saying pushing load now away from you over to Azure. And I've actually done a demo just like that. And so I know that works. I literally did that for a reason, to show that you could move. You remember that demo I showed you where the transactions are going around 3 clouds? We actually had all our users hitting it really hard. In this case, when you guys are hitting it, you're all on Amazon as a user. We actually basically made it so all the users were also load balanced across the 3 clouds, so their transactions were on all different clouds, and the transactions were still flowing across all clouds. That's a little bit more complicated than I have time to set up. Yeah, so you would have to have a global load balancer. And you can there's global load balancers from different third parties too, if you don't like one of the cloud providers.
Yeah, and still you can actually force the Kubernetes to spawn another node if you are running out of space, right?
Yes, right. You can always auto-scale a node as well, but not based on load. All right, it's based on CPU saturation and memory saturation, not based on HTTP traffic by default.
So actually, so I'm trying to understand. So we have a set of nodes which we set up initially, right? Mm-hmm. Then we start spawning out Knative ports.
Already? You use Knative now?
No, I'm just
okay.
Hypothetical situation. We started spawning Knative ports.
Yeah.
Is there a way to detect that Knative is going to run out of the nodes and spawn another node?
I don't think so. I could go back to the engineering team on this and find out. I don't believe so, but here's what it would happen, okay? The autoscalers built into Kubernetes and OpenShift are based on CPU and memory load, right? That's what they're looking at. So if I go back to this screen here, you can see my CPU and memory are good. I got lots of headroom here. But if, in fact, they are at 110%, and I forget what the max, it's over 100, but I don't know how far over 100 you can go. And you can decide that. But if they were all at 100, and Knative was like, crap, I got to bring up more pods based on this user load, HTTP load, or Kafka load, it's the same either way, right? If either of those loads grow, I need to bring this thing up. And it says pending. It's pending because there's not enough CPU or memory in the cluster. That alert is going into the OpenShift cluster or the Kubernetes cluster, and the autoscalers do pick up on, oh, there's not enough memory and CPU. Let me launch more worker nodes, but it takes 10 minutes, depending on your infrastructure. On Amazon, I've been tracking it as probably 8 minutes to 10 minutes. So that's what it takes to bring up a whole new instance and add that node to the cluster. I mean, here, we won't sit here and wait for it because we don't have time either, but here, I'll show you. I don't have it automatic. Oh, crap. But I'll show you what it's right here. So I can come in here right now and say, I would like a new machine in this availability zone. So I'll say it's just like pods, but it's nodes now. And if you look at this node user interface, you can kind of see, come on, machines. There we go. See, there's a machine coming online, but there's no node associated with it. It's not a Kubernetes node yet. It's just a naked machine. That'll fill in a few minutes, 6, 8, 10, 12. I haven't timed it perfectly, but I know it's several minutes because I got bored of watching it one day. But it'll fill in, and then you can schedule stuff to it, or it'll schedule stuff to it automatically.
So actually, that's a point where we have to pre-scale.
Yes. Yes, if you know you're going to overrun your node capacity, you need to kind of scale that out to the point of what you think is the right equilibrium, because that just takes too long.
Okay, so can we scale based on like percent of the CPU or memory?
Based on a percentage of available memory or CPU? Yes, right? So because that's what it's looking at. This auto scaling, which I just did the manual scaling event, is based on memory use and CPU use, and you define what that is. Yeah, and by default, I don't have any autoscalers configured to my cluster here. Is that under here? I don't, it's in here. I've never tried to configure it, but yeah, you would configure the autoscaler for determining when to grow the nodes, if you will. And so this one's happening. Let's see if I can go see it real quick. This is kind of fun too. Log in. Looks like I'm not logged into the. This one's running in Ohio. I run things I run in Frankfurt and Bangalore and things like that, just to see how it works. Oh, this is in California, not California. This is Ohio. And let's see here. 8 instances. See it right there? There, it's coming online. Oh, come on, scale in right here. So this one right there. It's that one right there. It's coming up. And then once Amazon's booted the VM, right, then Kubernetes gets installed on it, and then it's now part of the scheduler. It takes load from our perspective as users, right? But we've already killed a few minutes waiting for it. It'll take a little while longer.
So Kubernetes gets installed in it, or you don't use the pre-built images for that?
I actually don't know. I'm sure there's a pre-built image on it, but keep in mind Kubernetes itself is also dynamically installed, right? It's and this is CoreOS based. Okay, looks like it passed its checks now. So but there's still a little bit more that it's going to be doing to it. See, it's still not a node yet, so there's still something else happening. So I don't know what all that is. It's CoreOS based, and there is still things being pulled and downloaded to it. Again, we want to make sure everything's patched as much as possible, right? This is a system that automatically patches itself as well. Kind of an interesting technology. But that's more, I'm not really at the infrastructure level at that level, right? I let other people at Red Hat. We have a few thousand people at Red Hat that are at that level. I kind of come at it more from the Java perspective. Okay? And so we've had a nice, interesting discussion there, but I want to kind of show you this Knative serving thing so you get your head around it. Let's show you this. I drew this picture to help people understand. When you build an app and you build an image, you create this deployment YAML. Okay, now there's easier solutions to this. There's Helm, there's S2I, source to image capability, which OpenShift has. It's also an open source project. But basically, there's all these other ways to get your code running in Kubernetes. I'm showing you the bare bones Kubernetes way, right? You create an image, push your image someplace, your own local registry, Docker IO, GCR IO, Quay IO. You put your image someplace. Then you throw your deployment YAML at the Kubernetes cluster. It gives the image it has the image identifier there. It does the pull to the node, right? It has to download the bits to that node, and then it has the deployment, the replica set, and then starts launching pods. If you say you want 2 replicas, you'll get 2 pods. If you say you want 8 replicas, you get 8 pods. It's a very simple model, and then you have the service interfaces with it. So this is the standard way of thinking of Kubernetes. Here's what happens in Knative land. So look carefully here. These guys right here are all right down here on the right. So they're still here. It's just that now you have the Knative service, which begets and creates a configuration, which has a route, which creates a revision. And then there's some more parts to it, the pod autoscaler, the virtual service activator. And they've changed this recently. This is no longer the virtual service. And the activator is actually hard to see now. But the concept is that this is all the infrastructure they put in place to do the autoscale from 0 based on user load. Okay? Because by default, in the old way, if there's no pod, there's nothing to respond to a user. The user gets a 503 or 404, whatever they get. In this case, it holds the load, scale up, scale up, scale up, then send the traffic through. And that's what all this other stuff is. So here's the thing. Think about it. I showed you I have these deployments, kubectl get deployments. And you can see I'm all at 0 pods now. Deployments, you can see it's all 0 for 0. I still have my replica set, get RS. You can see they're all 0. And I have no pods. Watch kubectl get pods. And then I have all this other stuff. kubectl get kservice. You can see there's these K services now, and that is the Knative service. And there's all these other things. kubectl get configuration, get config. I can get the revisions. I can get all these other things. And let me kind of show you this. kubectl get endpoints. All right, let's see here. Notice the endpoints. Let's see if we can do this. Watch kubectl get endpoints. I don't know if this will be obvious or not. This is a kind of a tricky thing to see. Let's see if we can see it. I'm going to put some load back on it. That should make the Quarkus app come back to life. Okay, and if you watch closely, you'll see actually the endpoints change, but I think it's not even on screen here. Let's try it. Yeah, so this is may not work because I can't even see the Quarkus one. So it changed. So it's these guys down here. See that right there is the endpoint. 72, that is in fact the pod endpoint. Notice this one though for node and booted, Spring Boot, a little bit different. Let's see here, can poll. It's hard to demo these things. That's why I use all these little windows. Again, so we're bringing up node. Notice it's 0 of, and notice there's 2 sidecars now, right? There's the Istio sidecar and the Knative sidecar. That's why it's 3 of 3. And watch the endpoints, though. So this endpoint should be the activator endpoint IP address. And see what it did there? Now it's actually going to that one. And if I do my kubectl get pods, show labels, and let's see. Oh, not show labels, sorry. Get pods. This one, let's just do this node. Notice that it has a very funny pod name now, and because Knative is generating that automatically. Describe pod, and so yeah. So if you kind of notice there, that's the pod IP address. So the pod IP address gets mapped to the endpoint when the pod is alive. When the pod downscales, you'll see the endpoint change back to what's called the activator. Yeah, so this one's going back to the activator now. kubectl get pods, and there should be no more the Quarkus one. No, it still says it's up. But it is kind of one. Okay, no, it is terminating. So that's why you see what's happened here. So the way to understand this, and I guess we're out of time, but the way to understand this is most of what you see, all this magic you saw today, at the end of the day, is manipulation of this thing called IP tables. And actually, it's no longer IP tables as of this very moment. It's switched to something else called IF tables or something. I have to go look. The Linux guys actually care a lot about this. And it's like, but what's happening is, with IP tables, one of the things you could always do at the Linux level is you could always change the routing logic associated with a computer, right? Basically, stuff comes in on this IP address, send all that traffic to this other IP address, this IP address, this IP address. You just basically move the packets any way you want. That's the beautiful thing of IP tables. You can constantly change that. And so if you think of how the service works, you think of how the Knative service works, you think of how the virtual service works, that's what they're doing, okay? So the service who's load balancing across the different pods, that's because it can manipulate IP tables. They can say, hey, let's go this way and this way. What Envoy is doing is manipulating IP tables. What Knative is doing, what you just saw here, is manipulating IP tables. That's really what's happening at the underlying Linux level. It's simply changing way packets flow in all these very, very clever ways so it can do these interesting things. That's how they defy the laws of gravity and physics with their, hold the traffic until there's something ready. Something has to hold the traffic. You can't have things going to nothing, right? Transactions or things coming across the internet have to have a port to connect to, a socket that is open, bits are flowing, bits can't just go nowhere. Somebody's got to buffer the bits that are coming over the wire until such a point there's a pod available to send the bits through to. So that's what's really happening here. And so if I go back to Quarkus, KN polar. Okay. Why is it not completing? What did I do? Dot KN polar. And then we can make this the last bit here. So it's going to, now it's applying load, and we should see this change to the real IP address of the pod. Once the pod is up, it has a real IP address. So it's a very subtle thing, but it's, you know, this is really the magic of how this stuff works. So I don't have my watch for my pods, so it's initializing. So let's bring those pods up. Come on, pod. And then we'll see the endpoint change if all goes well. So it's got to go 3 by 3, though. Oh, man, look, I did get an error here. This is new. These errors did not occur before. But there it goes. It's now running. And you can see the endpoint change to the real pod IP address. So that's kind of the magic of how this thing works underneath the covers. One thing I should just show you, though, if you look at the code is slightly different than what you might have expected. It looks like you would look like a standard Spring Boot app, standard Quarkus app, standard Node.js app, but for one subtle difference. Oh, this is not even the one. Let me bring up the right one. One subtle difference in the actual code itself. And that is right media greet. It's the get. This is not right. Okay. I'm looking at the wrong thing entirely. Something's not quite right here. Let's look at this one. And who knows? I've made so many changes on this application, on these things. So right there, get. Oh, interesting. This is not set up the way I expected. I know why. Okay, I've now confused myself. Let me show you this, though, and then we'll let you guys go after we tell you one more thing, because I want to see the code is slightly different. But where is the code slightly different? Oh, wait. Okay, native tutorial, and I'll just tell you that in a second. And app. And greeter. If you use Knative eventing, we've been only looking at Knative serving. If you use Knative eventing, you will see that the code is slightly different, and it's only for one reason. Knative eventing always looks for a post on root, and what you get is a JSON payload, which is a cloud event JSON. So Knative eventing, which abstracts the inbound logic from the load, right? The load could be Kafka, it could be FTP, it could be AWS SQS, it could be GCP pub sub. Knative eventing's job is to abstract all that and still give you the auto scaling and all the magic that you saw earlier with HTTP. But if you don't want just HTTP, you want Kafka to do that, you want Amazon pub sub to do that, it's going to come through this post method. So you got to have that method, and you got to accept JSON, and you got to know it's JSON coming. That's all. And then you can map it any way you want in your logic. So that's the difference between Knative eventing versus regular Knative serving. And so let's kind of wrap things up. As I mentioned, there's this thing called Tecton, which is Knative build. One thing I want you guys to be aware of in this deck is all this other set of resources. I actually run 3-hour sessions on Istio and 3-hour sessions on Knative with O'Reilly every month, approximately. There's the intro class for this was 9 Steps to Awesome. There's a recording here. And here's the link to the slide deck. And here's a link to the Istio tutorial, which actually walks you through everything we did today, but you can do it on your own laptop. Okay? We have it all documented. It's called the Istio tutorial. Their slide deck for that is Istio intro. The same thing for Knative. We got a big, long tutorial document. It's all GitHub markdown files, right? And so everything on GitHub. The Knative tutorial walks you through everything I showed you today, plus a little bit more. And that's also this presentation deck here. There's also a Quarkus tutorial that we've been working on, my team specifically. And again, we give you the slide deck, as well as, and there's a recording. So like these two guys don't really have recordings per se. The 9 Steps does have a recording out on YouTube. These two I'm still mostly running live with audiences. I just haven't had a chance. O'Reilly's been after me to sit down and record it. I just haven't recorded it yet. But you can at least get the documents that you can go through on your own. So like, let me pick on Knative here, or Istio, and bring that up. And come on. Uh-oh. and then you can go to it. Come on. So I have right down here, and you can look at the HTML version, and you can do these same things yourself. All right, so I did all these things with you guys, but you can kind of do it all on your own. All right, well, that is all we have time for today. I thank you so much for your time. One other book recommendation I would make, if you're going to be practicing microservices, Edson Yanaga actually was here in Krakow just a couple weeks ago. He came in to visit the Sabre team. But he wrote this book that specifically helps deal with the microservice database problem. If you're trying to get out of the microservice world or monolithic world where you had a single code base, single team, single database, now you're going multi-team, multi-pipeline, multi-microservice, and multi-database. How do you deal with that? So this is a phenomenal book that gives you a lot of tips and tricks on strategies for how you deal with your database. That's a very, very common set of issues. Did you check that out? And let me see, I'm going the wrong way. And there's a bunch of other links in here also. So this is all part of this deck, bit.ly 12 Ways Cloud. And you guys have access to all these things. Again, more free ebooks. But this is all on microservices. This is on Vertex, reactive microservices. There's not one of these books for Quarkus yet. Quarkus is still too new, just born in March. But we'll do one of these books maybe, January of next year or something like that. We'll get working on that. And so my last quote for you, don't fear failure, not failure, but low aim is the crime. Think about that for a second. Yes, sir?
Do you have any recommendation regarding where to keep the private keys and things like that, used by the bots?
I don't think I understand the question.
Keys.
Private key?
Yeah.
Oh.
What kind of vault or what do you
Yeah, so,
for
I don't know if Red Hat has a recommendation, but people really like HashiCorp Vault. They do.
That's the only one which I know. I was thinking maybe you recommend.
There are definitely some others out there, but I've never tried to drill down on that one with anybody. It has come up inside the company a few times. It's like, what do we recommend? And the answer was, we don't. You know what I mean? This is actually the most popular by far, HashiCorp Vault. And, but let me check this out. Hold on one second there, because it might be that there's something here, right? We are very focused on everything that shows up here in Operator Hub, because we want the people to have the additional operator capability. Let's see, let's map, security operator. So one of these might be a Vault-like thing, and I think Vault's in here too. I'd have to go look. I haven't had a chance to dig into all these guys yet. There's Hazelcast, Insight, MSQL, metering, MicroRocks. There's a lot of interesting things here. And so we are trying to get more of the ISV ecosystem to provide an operator, because that'll be the easiest thing to use within the context of the cluster. Like the Kafka thing I showed you earlier, right? Basically you now have this new object type. But thank you. We can go ahead and shut down and let them stop recording, because I know this gentleman's tired of holding this camera. But thank you also so much for your time. I'll be here for a while longer, though, and I can answer whatever the questions you might have. Thank you. Yeah, so come up and see me. Thank you.